Okay, good afternoon for everybody in Europe. If there's anybody from further away, good morning or good evening. First up, a bit about me. I'm Patrick Barel. I've been doing Oracle since about 97, mostly SQL back then. In 99, I started doing PL SQL as well. And actually, I've been doing that ever since. I did a little bit of Apex, but that was just a bit of playing around. In 2011, I became an Oracle ace, mostly because I talk a lot on all these different conferences all over the world, nowadays all over my own room. And in 2019, I was promoted to Oracle Ace Director. I've written a couple of plugins for PL SQL Developer, which you can find on my own website. And I've also written a couple of articles. Well, sometimes I blog. I noticed my latest blog on my own blog is about a year old, but I blogged on the Qualogy website as well. I've written articles for all things Oracle, but that doesn't exist anymore. But they moved my articles to this location. And I also had my own column in the OTech magazine. And the OTech magazine doesn't exist anymore either. So I put the columns up on my own website. So if you have any publication you want to get rid of, ask me to write for you. Chances are it'll be gone soon enough. These are my contact details. If you want to take a picture, do it now. I'll make sure the PDF of the presentation gets distributed as well. So, as I said, I'm an Oracle Ace Director. If you want to know more about this, go to the bit.ly link, Oracle Ace program. And if you want to nominate, well, it says here yourself, but I wouldn't want to nominate myself. If you want to nominate someone you know, go to acenomination.oracle.com. And maybe I'll find some new colleagues in the ACE program. You all probably know about the always free tier, free database from Oracle. Only thing is, well, and a couple of more things on the Oracle Cloud. The only thing is you have to log in like every week to keep the databases alive, to prevent them from sleeping. On the Qualogy website, there's a 3-part blog post I've written on using a Raspberry Pi and some Python code to do this for you. So no worries there. Okay, back to today. Collection's a collection, no matter how small. I've got the title from the Horton Hears a Who movie, where he says, a person's a person, no matter how small. If you haven't seen this movie, go and check it out, especially with young kids. It's a lot of fun. Okay, Oracle was started in 1977. It took them about 20 years to get to Oracle 7. Before Oracle 7, it was just a database, and you could access the data using SQL. In Oracle 7, they added PL SQL to the database, which opened up a lot of new possibilities. There was PL SQL before in Forms, but it was client-side, and this is server-side programming. With PL SQL, they also introduced collections. Of course, with every programming language, you have variables, you have scalar variables, the varchar, the number, the date, but they also have collections, sort of like arrays. Back in Oracle 7, it was called PL SQL Tables, because PL SQL, and it was pretty much the same as a table. And if you have a single variable, a scalar variable, it can only contain one value. A collection can contain multiple values, but all of the same type. So if you have a collection of numbers, they will all be numbers. You cannot mix and match numbers and varchars in the same collection, except when you're using a collection of records. So how do you do this? Back in the day, like I said, they were called PL SQL tables. That's why I called the type names PT, PL SQL table, is a table of, in this case, the varchar 230. And then you had to put in index by binary integer. Back in Oracle 7, I really wondered, why do we have to do this? Because there was no other collection available. But I think they had a look into the future. Okay, you declare a PL SQL table type. Then you declare a names variable based on the type, just as you would declare a variable based on a number or a varchar. And then you can just fill it up. You can put in this case, varchars, the names, at any position you want. We'll put one in on position 1, then we put one in on position 42. And then if we put in something on position 10, Oracle makes sure that the order is preserved. So location of index number 10 is inserted in between 1 and 42. And then we can even use we can ask the collection how many items are there in there. In this case, I use names.count plus 1, and it ends up with 4. Because at the moment I'm creating this item, there were 3 items in the collection. So that's where names.count gives me 3 plus 1 gives me number 4. You can even use negative numbers. The index numbers are from -2 to the 31st plus 1 to something 2 to the -31st -1 something. It is actually amazing how many indices you can use. I've tried to fill up a collection with all the indices filled, but it broke my machine. It filled up the memory. So when I want to display everything in here, I'm using the loop. Go from the first item, and then use the loop. When the index is not nil, I'm displaying this, and then I go to the next item in the list. So it starts at -1, Haley, and then jumps to Hooli, Holy, etc. I even found an Oracle 7 installation, so I spinned up a virtual box with Oracle 7. It says Oracle 7.3, and I've created this program you just saw, this anonymous block there, just to show you that it really works since Oracle 7. Filling up a collection of variables takes a lot of time. You have a lot of code. And we work with tables. Well, that's mostly what databases are for. We work with tables. You can also fill up your collection using a select from a table. So let's create a couple of tables, the relation types, and the netmcdot. Netmcdot is the mayor of Whoville. You really have to go and watch the movie. So I'll create a table with the first name and the last name of the connection to netmcdot and the type, which relates to the relation type. And then I put in some data, relative, wife, son, daughter, friend, enemy, and a lot of peoples. persons there. In Oracle 7, we create a cursor, which does a select of the first name from the table where the type is 18, which is the daughters. And then we create a variable, a table of Varchar again, indexed by binary integer, and it's again called the names PL SQL type. And then we fill it up by selecting from the table. We open the cursor, we fetch a row, and we put it into the next item in the collection. And as soon as the cursor is empty, is done, we exit the loop. And then we can display the contents of the collection. In this case, I'm using the loop from first to last because I know all the items will be filled up because I started with count plus 1, which is the first one, and then added them up. There will be no spaces in between. This is a dense collection. Whereas the last one I showed you was a sparse collection, all spaces in between. You can use collections. You can also use collections as parameters instead of transferring a lot of separate values. You can group them into a collection and send the collections over to the other program. You can even use the collections within collections and send that into a different program, but that's kind of mind-boggling. Okay, Oracle 8, I didn't do too much with Oracle 8. I haven't even seen it, I think. Oracle 8i was the one we've all been using, or at least I've been using, and it introduced a couple of new collections. There was the Varray, that's the variable array, and the nested table type. The Varray and the nested table type can also be declared within the SQL realm of the database. So they can also be used in a table where the PL SQL table, which is now, by the way, renamed to index by table, cannot be used in a physical table. So in this case, we create a nested table. As you can see, we don't have the index by clause anymore. And if you don't have the index by clause, then it's a nested table. So we declare a type, we declare a variable based on this type, and then we have to do some more stuff because this is sort of the object-oriented way Oracle was thinking it would go. We have to initialize the collection. So we call the constructor function, names nt constructor function, and that just generates a placeholder. And then we extend the collection so we can make room for however many items we want to have. In this case, I've created room for 5 items, but I can extend it later on. I can extend it by 1 and fill that up, but this one is done this way. This also means I can only use the indices 1 to 5 in this case. I can use them in order, like I do here. I can also put something in 5 and then 3 and then 2 and etc. But in this case, I'm using them in order. And yeah, but for the rest, it's pretty much the same as the previous one, except this time I have to create the space before I can fill it up. And then to display it, I again use the first to last for loop. Selecting from a from a database table, like I did in Oracle 7, here's the same cursor and the same type for the collection. indexed by integer in this case. And now I open the cursor and I fetch bulk collect into the variable. That means I'll bulk collect everything. I'll select everything in one pass into my collection. The previous one in Oracle 7, I had to do fetch a row, put it in the collection, fetch a row, put it in the collection, etc., etc. Takes a lot of time. This one will fetch all the rows at once and put them all into the collection. Be aware though that this might, if the cursor gives you a lot of rows, it might be a problem with the memory. And now we can we can run the for loop for index first to last. In this case, we can also go from 1 to count, because doing the bulk collect, Oracle will always fill a dense collection starting at position 1. Another thing is, if you do a bulk collect and there's nothing in the cursor, you will not get a no data found. You will just end up with an empty collection. So you'll probably have to check for that. Like I said, be aware that if you fetch a lot of data, it'll be fetched into memory. And chances are you're not the only one on the database. So if you're using like 100 megs of memory and there's 100 people working there, you get 10 gigs of memory in usage. Probably not a good idea. Oracle has a solution for that. Besides using the bulk collect, you can also limit the number of rows being fetched in one pass. In this case, you have to do a little bit more work, because you have to open the cursor and then you have to start the loop. In the loop, you'll fetch a certain number of rows. In this case, the limit is 4, but you'll probably end up with the limit of 100 or 1,000 or whatever. You fetch the rows into the collection, and if the fetch resulted in more than one row, then you'll display them. If the cursor is empty, if you're done, then the fetch will result in an empty collection. So the count will be 0, and it will exit the loop. If you want to select more than one column, you have to create more than one index by integer collection. And then you can select, create a cursor which selects multiple columns. You'll have to create multiple variables of all these different collections. And then when you open this, you can fetch every column into its own collection. In this case, I'm doing the bulk collect again without a limit, because I know there's only going to be like 18 people there, 18 daughters. This isn't much of a problem, because if you're just selecting a couple of columns, but if you want to select a whole wide table with like 50 columns or 60 columns, chances are you're gonna miss one. And what if there's gonna be an extra one? Luckily, well, this would mean you would have to create a lot of collections, a lot of variables, etc. And Oracle will help you with that. I'll come back to that. Like I said, the nested table can also be created in the database. When you do a create or replace type nested table as table of Varka2 32, this will create a type which you can use in your PL SQL code, but also in your tables as a column. And I'll create a package with two functions, daughters and relatives. And in the body of the functions, the daughters will just give me two daughters. I'll create a variable, extend it by 2, making room for 2 items, and then filling it up and returning the nested table type back to the caller. And for relatives, I'm using the select into, select bulk collect into my names nested table. In this case, I don't have to initialize it. Oracle will do that for me. And then in SQL, I can select the column value, which is the name of the column from a nested table, and then I have to do table cast the net McDot or the McDot daughters or McDot relatives. This is the function. We have to cast that as a nested table, names nested table, and then we can select the column value from it. This is Oracle 8i. In 9i, this is a bit easier. First of all, let me show you how the version of Oracle 7 still works in Oracle 9i. The types, no, in this case, sorry. In Oracle 9i, the index by integer collection was renamed again. It was now a associative array. And this time we can use a varchar as the index. Instead of the binary integer or the PLS integer, which we used before, we can now use the varchar as the index. And it still fills it up. It pretty much the same as the one before. It fills it up using the alphabetical order. So holy and then heady will come before holy. So the order is being maintained by Oracle, even though it's text this time instead of the numbers we had in Oracle 7. And in this case, you can never ever use a simple for loop. You have to do go to the first and then go to the next until you're at the end of the collection, because this is by default a sparse collection. Remember in Oracle 8i when we had to create a lot of collections and a lot of variables to select all the columns from a table. In Oracle 9i, we can now create a table of the physical table percent row type. So this will give me a collection of records which are the same as which look the same as the netMcDot table. And then in my cursor, I'll just select the rows of the columns I'm interested in and the types I'm interested in. And then instead of fetching into a lot of collections, I now just have to fetch into this collection of records. Yeah, the same way we did in Oracle 8i, we create a nested table in the database, and then we create a function which just gives me a couple of rows back. In this case, it is pipelined. Pipelined is a new keyword, and I'll show you in the implementation. Instead of creating a nested table variable, I'm just creating the row and filling it up. And instead of adding it to my collection, I pipe it out of the function. So it gets sent back to the calling process. And then I'll create the next row and I'll pipe that one out as well. And at the end, there's nothing left to do but return control. So I still have to do control. And for the relatives function, it's pretty much the same. In this case, I'm doing a for loop, cursor for loop on the table. And then for every row, I'm piping that out. This means that the calling process can start working on the rows as they are created, as they come out of the function. We don't have to wait until everything is done within the function. And the select, what we had to do is select from cast the function, the table function. Now we will just have to select star from table and then the function name. That's a lot easier as well. Everything always gets easier. In Oracle 9i, I have a table fat mugdot, which is 10,000 times the rows in the net mugdot table. And if I select the count from there, it'll give me what 20,000 rows or something. And then if I do a very simple thing, I'll just open a cursor for loop and do nothing much, just get the ID into the local variable. It'll take me about 4.5 seconds. Sorry. In this case, it's a row by row. So it's fetch a row, put the data into the variable, fetch the next row, etc. Row by row or slow by slow. If I rewrite this code and build a cursor, build a collection on that cursor, a variable on that collection, and then open the cursor, sorry, fetch the cursor, bulk collect, limiting it into steps in sets of 10,000 rows, and exit when I have nothing to do. In this case, it's exactly the same code as I had before. It'll take me about 1.2 seconds. It's a lot faster. So just by doing a little bit of work more, my code gets a lot faster. Oracle 10G came around, doing exactly the same. Dropping the table, creating a table with a lot of rows, and then executing the simple piece of code again. In this case, it took me about 0.7 seconds. That's a lot faster because Oracle got a lot faster. My database was more quiet. I had more memory. There's a lot of things that came that improved the speed of this process. Now, but what if I do the update to the code like I did in Oracle 9, where we went from 4.5 to 1.2 seconds? In this case, if I run this, I can go from 0.7 to 0.5. So Oracle does a lot of optimizing already. In the Oracle 10G database, since the Oracle 10G, if you have a cursor for loop, like the one I had over here, if you have a cursor for loop, Oracle will optimize it and write something like this, with a fetch, limiting it into sets of 10,000 or whatever. As long as Oracle is sure that the program will not behave differently, except it will go faster. So yeah, that's great news. We don't have to do anything, and Oracle does the heavy lifting for us. In Oracle 9, we had to create the names nested table type as a physical type in the database. In Oracle 10, we can create the nested table type as a type within the package. So we can still build the exact same code, but this time we use the nested table type inside the package. And we still have the pipeline function, so we'll pipe out the rows as soon as they're done. Nothing really changes, except we don't have to create a nested table type in the database. Sometimes you don't have the authority to do that, but you can create packages instead of other objects. Oracle 11, nothing really happened concerning collections. There were speed improvements again, and I think Oracle's own usage expanded on this, but no new collection type, no new syntaxes. What we cannot do in Oracle 11, we could create the nested table as a type in the package, but if we do that, we cannot select from it from PL SQL. So we cannot create a daughter's nested table type, fill up the nested table into the variable, and then select from it from table daughters. That was not possible. What you had to do is create a physical type, a SQL type, and then you can do the code as written before. You can execute this in PL SQL. In Oracle 12, we can now create a nested table type inside the package and still select from it. So that's a lot better, a lot easier. We don't have to create a physical type anymore. And what's even more good, even better, is we can use the simple, the easiest collection, the associative array, within the package. And then we can just select from an associative array, but only from within PL SQL. If you want to try this from SQL, it will not work. It only works from when you're calling SQL from within PL SQL. So that's, yeah, using the associative array is the easiest one. So that's a good one. Oracle 18c. Remember, back in Oracle 7, this was all the code we had to do to fill up a collection, create a collection. In Oracle 18c, we can now use qualified expressions. So we create a nested table type or an associative array type variable, and then we use the variable, and then we use the constructor of this associative array using at position 1. We'll put it in Hooli position 42. We put in something. Only thing is, I'm using lnames.count plus 1, which is the same as I did here. But lnames.count gets evaluated before we putting something in here. So lnames.count plus 1 will result in position 1, overwriting Hooli. If you have a collection of records, it gets even more complicated, or it's more verbose what you want to do. You create the record, a collection based on that record, a variable based on the collection, and then you fill up the collection at position 1. You put in a record, first name. It's a lot more typing, but it's a lot more self-explanatory of your code. Yeah. Then Oracle 19C. Nothing much happened again, and no real new features. I think Oracle focused on because 19C is the long-term support release, they focused on stability, and they're using collections themselves a bit more. Oracle 20 didn't happen because of a pandemic. Oracle 21C, well, we can still do the fill up the collection like we could back in Oracle 7, which is 25 years ago, just about. Displaying the collection. In Oracle 7, we had to go from first to last. Sorry, first and then using the next and then jumping over the gaps. In Oracle 21C, we can now use the for indices of. So instead of going first and then next, and we go to the indices of the L names. And this will just pick up the indices -1, 1, 4, 10, 42. You may have seen indices of when you're doing the FORALL. The bulk collect is fetching the data from the database. The FORALL is the bulk version of sending data back to the database. And you can use indices of there as well. Another one we can do is we can use values of. So in this case, we're gonna use the values of the collection, and then we'll just put out the index, which is the values here. But these values will be alphabetically ordered. Not true, sorry, skip that. These values will be displayed in the order of the collection. So -1 first, and then 1, and then 4, and then etc. And another one in Oracle 21, we can use the pairs of. So we have the index and the value, and then we use the pairs of the collection. So we don't have to go back to the collection here. We just use the index, which is the one, the numbers here, and the value, which are the values here. And then we can display that. What am I doing? Pretty good. Okay, so like I said, this presentation was inspired by the movie Dr. Seuss, animation done by Blue Sky. If you want to know, learn more about this, I've got a couple of articles which I've written for All Things Oracle, but you can go to the links here, collections and the bulk processing. And if you want to know more about the easy initialization for records and arrays, go to the Oracle blog. Of course, you can always go to Oracle Base, which is my go-to site for anything. All the scripts I've shown you are available in Live SQL. If you go to livesql.oracle.com and search for collection, you'll find all the scripts there, and they should probably all be working because, yeah, or Live SQL is 21, 19. Now maybe the ones for 21 don't work yet. These are my contact details. I'll send the PDF to the organization